Let's talk about hydrocarbons. So again, a lot of organic compounds, of course, have carbon, but then when they form their long chains, and they sometimes need like a fourth bond or maybe 3 extra bonds or however many extra bonds they need, those extra bonds tend to be filled in by lots and lots of hydrogens. Okay, so lots of organic compounds are hydrocarbons. They're made of hydrogen and carbon, and they tend to. We have like kind of 3 families of hydrocarbons, and we call them homologous series. Homologous, remember, homo means same, so it's like instead of calling them family, we kind of call them like sames. And here are the 3. So we have 3 types of hydrocarbons, 3 families, 3 homologous series. We have alkanes, alkenes, and alkynes. So very similar names. See if you can tell the difference. So take a look at alkanes. What does this alkane, methane, ethane, and propane, what do these 3 have in common? Moving down. How about alkenes? What is it? Ethene, propene, and pentene. Looking at the picture, what makes these alkanes and these alkenes? Okay, and then here's alkynes: ethyne, propyne, butane. Looking at the picture, what makes these alkynes and these alkenes and the other one alkanes? And you can certainly see the naming, the endings. All right, so if you guessed, alkanes have all single bonds between them. Alkenes have double bonds, and alkynes have triple bonds. You figured it out. All right, so alkanes, all single bonds. Alkene contains just at least one double bond, and that's between the carbons. Everything inorganic is about carbons, whereas alkane is going to be all single. So that alkene could have lots of single bonds in it, but as long as it has one double bond in there, that is going to be an alkene. Alkynes have to have at least just one triple bond in them. The rest could be all single bonds, but at least has to have one triple bond. So the way I remember it is like alkene, I don't know, that double bond kind of looks like an equal sign to me, like alkene, I don't know, equals. And then alkyne, ine kind of reminds me of like tri for triple bond. You do not have to memorize that, though. You probably will by the end of it, just from using it so much. But alkanes, there is this chart, actually, this is not. All of page 7 in the reference tables is about organic. So alkanes, and then here's a picture, and you can go, oh yeah, that's the single bond one. Alkenes, some information, picture, oh yeah, that's the double bond one. Alkynes, try, picture shows that's the triple bond one. So you can get it all from the table if you can't remember it. So where did these get their names? Methane, ethane, propane, ethene, propene, pentene. Where do those names come from, and how can I figure them out? It's actually kind of not that hard, and it makes you feel really smart because then you can name all these organic molecules. So take a look at methane, ethane, and propane. Where do you think they get their names? Okay, so where does the ane come from versus the ene? And then where do these beginning parts come from? Meth, eth, prop, pentane. Maybe that might give it away for you. Pentane. Why is that called pentane? All right, so if you guessed that the ending, like ane, comes from whether it's an alkane, alkene, alkyne, single, double, or triple bond, you're correct. So let's talk about pentane. So if we were naming pentane, where does that name come from? So if you guessed the ane is because it's all single bonds, that's correct. And then where does the pent come from? If you said, oh, I know pent, like pentagon, or octane, oct, like octagon, that is the, what five, so pent means five, but five of what? Five carbons. So if you notice there's five carbons, that's where the pent comes from. All right. So the names of hydrocarbons are just the beginning is how many carbons there are, and the end is whether it's alkane, alkene, alkyne, meaning all single, a double, or a triple bond. Here are the prefixes. One is actually meth. So yeah, the name meth, as in the drugs like methamphetamine, there probably is somewhere in there. That's like a maybe shortened common name, but probably there is like one of something. Eth means two. Prop means three. Four is but. Oh, we pronounce it bute, like butane is what's in like handheld lighters. Pentane. 6 is hect. 7 is hept. 8 is oct. 9 is non. And 10 is dec, as in decade. So a lot of those you might have memorized, but you don't have to memorize them. So this kind of stuff is always on the good old reference table, and it's right next to the last table we looked at. All the organic stuff's on page 7. So here we have on table P all of the organic prefixes. You don't have to memorize. All right, so I'm making an organic compound, a hydrocarbon, for you to name. And so I put 4 C's in a row, and then I'm just like making sure every C has 4 bonds by sticking H's on it. So now this C has 1, 2, 3, 4. That's not supposed to be a double. I was trying to trace it. This C already has 1, 2, 3, so I'll just give it one more. You will start to notice when you draw a lot of these that it's kind of annoying to always be drawing like H, 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 H. So what you are allowed to do in organic chemistry is just draw a line like that, and it's assumed to be an H because it is so annoying to draw so many H's. So if you want, you can leave it like that. The only danger in that is sometimes then when you're trying to like count H's, you miss them because they're just like lines, so you don't see them. So anyways, I could leave it like that, or I can go ahead and put the H. So let's see if we can name this organic compound. So let's see. I like to start with the ending and work backwards. So I have 1, 2, 3, 4 C's. So that's bute. Okay, not counting the H's. Everything in organic is all about. Oh, I said I was going to start backwards. I didn't. Everything in organic is all about carbons, so it's how many carbons are there. And then the second part is it butane, butene, or butyne? So that's where we look for how many, whether it's single, double, or triple bonds between the carbons. So if there were some like double O over here, that wouldn't matter because organic chemistry is all about the carbons. So I see all single bonds, so that is ane. So this is butane, so that is what is in a like a handheld lighter. If I were to put like a double bond in here somewhere, I'd have to like change the H's because now that changes like how many bonds the C has. It can't have more than 4. Now I have a double bond in there. What would I change this ending to? Now this isn't butane, it's butene. Okay. Let's say I get rid of that. And let me get rid of one of the C's. So now I only have 3 C's. So now instead of butane, now it's 3 C's, so it's prop. Prop with an ane ending, propane. And that's what's in like a gas grill. If I had 8 C's and single bonds ending, it would be octane. And that is what's in like the gasoline that you put in your car. So just to summarize the naming rules, the first part, the prefix, eth, meth, prop, bute, pent, hept, hecta, octa, non, dec. Those all tell you how many carbons there are, not how many atoms, not H's, not O's, how many carbons there are, because organic's all about carbons. And you don't have to memorize those. You'll probably memorize some of them, but they are all on table P. Like 7's usually a hard one to remember if you need to look it up. And then the ending, ane, ene, or eine, comes from whether it's ane is all single bonds, ene is just at least one double bond in there somewhere, and again, it's between carbons because organic's all about carbon. So if I had a C double bonded to an O, that's not it. But if I had a C double bonded to a C, that is an alkene. That's a double bond between carbons. And then an ine is a triple bond between carbons. And remember, this can all be found in the reference tables right together. Table P gives you the prefixes, and then right below it, table Q gives you like the names and a picture and some more information we'll learn next.